All right, so this is a recap for BCR 1.1. So this is all about Lewis dot diagrams, and the objective is use a periodic table to represent Lewis or valence electrons in Lewis dot diagrams and determine ionic charge. So the big thing that you're going to need to know is you're going to need to know how to read the periodic table. This is all based on your understanding of objective 5.1 for the ASPT unit. So if you can read the periodic table and know the group numbers, then you should be able to determine valence electrons, and then on top of that determine ionic charge. So if you're struggling with this objective, it's probably because you haven't mastered the objective previous, which was objective 5.1 in the ASPT unit. So we have 4 examples here that I'll go through pretty quickly. This is a pretty straightforward objective. So beryllium, if I find beryllium on my periodic table, beryllium is in group 2, and that means it has 2 valence electrons. So the Lewis dot diagram is just representing the valence electrons, and the whole point of this objective is to prep us for getting ready to bond things. So beryllium looks like this. Okay, you always start at the top and you work your way clockwise, just like you would do in your Bohr models. So beryllium has a Lewis dot model that looks like this. Okay, aluminum is in group 13. All group 13 elements have 3 valence electrons, so aluminum's Lewis dot looks like this: 1, 2, 3. Okay, germanium, group 14. All germanium or all group 14 have 4 valence electrons, so 1, 2, 3, 4. And then oxygen is in group 16. It has 6 valence electrons, so it is going to have 6 dots around. So what I just did there is I looked at the group, I then determined the number of valence electrons, and then it's just a matter of placing them around, starting at the top, working your way clockwise. After 4, you then double up. Okay? The second part of this objective is being able to use these models to determine the ionic charge. So the ionic charge for beryllium is positive 2. And the way that I know this is it's trying to get to either 0 or 8. 8 means you're adding electrons, 0 means you're taking away. And you're going to do that in the easiest way possible, meaning like thinking about rounding, which way is closer. So beryllium takes away its 2 because the previous shell was full. So the ionic charge then would be positive 2. Okay? Aluminum is going to take away these 3 because that's closer than adding 5. So if you take away electrons, remember you're taking away negativity, you will then have a positive 3 charge. Germanium, you have 1, 2, 3, 4. This one is weird, okay, because it's directly in the middle of 0 and 8. So therefore, you're going to have positive 4 or negative 4. Okay, that does matter. You will need to be able to know that both of those happen. And then oxygen. On the other side, we have 6 valence electrons. So if we have 6, we're going to gain 2 electrons. And when we gain 2 electrons, we are going to have a negative charge, and it's going to be negative 2. So your objective, again, is to use the periodic table, determine valence electrons, and draw the Lewis dots, which was here. And then from the Lewis dots, you should be able to give the ionic charge. Okay, there is a ton of practice on Schoology. If you have questions or you need extra practice, let me know and I can help you. Good luck.